Hey everyone, and welcome to AC Academy. So today we're going to be focusing on Algebra 1, section 1.2.4, and that's writing linear equations, linear functions from plots. Okay, so let's step into it. The question states here that write a function that models the plot from month 2 to month 9. Okay, so let's take a look at this plot. So this is just showing, overall, this is showing the temperature with respect to the month of the year. So on the x-axis, we have numbers 1 through 12, actually 0 through 12, but the plot starts at 1. And then on the y-axis, we have the temperature in Fahrenheit ranging from about 83 to 115. Okay, so let's take a look at month 2 here, which I'll circle. And on month 2, the temperature is this value, which is going to be 99 degrees Fahrenheit. We'll go ahead and fill that in and circle this value here. How do I know it's 99 degrees Fahrenheit? If you look at the scaling of the y-axis, so we know that this mark is 85, this mark's 89, this mark's 93, and 97. And there's one mark between each, so we know this step size is 2. So 85, 87, 89, 91, 93, 95, and so forth. And that's how we got 99 for month 2. And let's write this out on the side. So month, and then we will have temperature, right? So this is asking, write a function that models the plot from month 2 to month 9. It's asking for, well, the subject matter is a linear function. So if you look at the plot, I guess the first question you would ask is, hey, looking at the temperatures, this plot isn't linear, right? You go from this value to some of these values, and you move around here, something like this. Yes, and that's why you have to pay attention to what the question is asking. I think there's going to be, there could be a few questions that ask you something like similar to this and say, hey, represent this stuff from, I don't know, this plot, right? This one specifically is asking month 2 and month 9, and it's telling you to write an equation based on these two values only. Now, the question should probably say only, but if you do have a question like that, I'd probably say go ahead and ask the exam provider, or if this is homework, ask the teacher, the professor, whatever it is. Now, taking a look at this first value, we have month 2, and we know the temperature is 99 degrees F. Let's take a look at month 9, which we're going to also add to this table, month 9 here, and we're going to go up, and we know this value is, so this line right here is 111. It's in between 111 and 113, so we're going to call that 112. Okay. Now, the second thing we got to know for this problem is the standard equation, the standard linear equation format, which is y equals mx plus b. Okay. So how do we solve for all of these, right? We have our y values here, and we have our x values here. And we have 2 points on this plot. So the first thing I would do, we know that m is your slope, which is equal to rise over run. We have our values here detailing x, the run, and y, the rise, right? Sorry, and I wrote these backwards here. This one should be x and y, as it is per this plot. Now, if we want to create the slope for this plot, which I will draw in red, going from month 2 to month 9, and that is the straightest line I can make right now, we can do this. So rise is detailed as the rate of change from like one point to another in terms of the y values. And it's the same thing for the run, right? So this can also be seen, rise over run can be seen as delta y over delta x, or the change in y over the change in x, right? So for this problem, the change in y is given as 112 because that is the value at x equals 9 minus 99, which since that is the value at x equals 2, that is the change. Now delta x is the same thing, 9 as it was 112 degrees on month 9 and 99 degrees on month 2. Okay, so in one tip that it might come up, how do you know you're subtracting here instead of adding, right? Like how do I know it's not, I'm gonna put this in a different color. How do I know it's not, I'm gonna put some question marks around here too, so this is just a separate kind of note that you can look at and reference later if needed. How do you know it's not 99 minus 112 over, I don't know, 9 over 2, right? How do you know not to write it like this? Well, there's two tips here. One, you can look at the plot. Assuming you have a plot, look at the plot and you notice that your first point and your second point make a positive slope, as in things are increasing, right? Going from month 1 to month 2. So you know your slope has to be positive. Looking at these values, how do you, and you're dividing, right? How do you get a positive slope from these values? We know 99 minus 112 would give us a negative value up top. We know 9 minus 2 would give us a positive value down low, right? So this would come out to a negative answer. So you know that's not correct. How do you know it's not 99 minus 112 over 2 minus 9, right? This would be a negative, and this would be a negative, and that would give you a positive answer. So let's try that out, actually, right? So we have 99 minus 112. That gives us negative 13. And 2 minus 9 gives us negative 7, right? So negative 7. So M here, and I'm actually dividing this out just so I have a numerical value, is about 1.85 positive. One thing we notice the difference between these two, we know that on this one, month 9 is associated with this value, and month 2 is associated with this value. But on this equation, 99 is associated with month 2, and 112 is associated with month 9. This equation gave you the wrong answer because you're flipping the order of things, right? You're saying that the rate of change of temperature went from 99 to 112, and that went from month 9 to month 2. So you're doing it backwards technically. It needs to be, these two things need to be associated with one another, and these two things need to be associated with one another, right? So you can actually do this, though it's, I guess some might see it as backwards. It should give you the same answer as this. And let's try that out. So 112 minus 99 is 13 over 7, right? And that's the same thing as 1.85 here. So you get 1.85 here. You also get 1.85 there. Now let's look at our equation. We have y equals mx plus b. We have our slope. y equals 1.85 x plus b. Okay, so this is where we are right now. How do we get the y-intercept? So we know that the y-intercept, we get the y-intercept whenever x equals 0. So that's, for this linear equation, we get the y-intercept whenever x equals 0. So let's go ahead and plug that in. We know y equals 0, so we got 0 equals 1.85. Oh, sorry. We don't know what y is. There we go. 1.85 times 0 plus b, right? And we want to solve for y. So, excuse me, sorry. So we also have two numbers up here, right? We have these two points in time where we know the y value and we know the x value. So we can go ahead and plug those in here, right? So this is verifying that, yes, the y-intercept is whenever x equals 0, because we know that whenever x equals 0, y equals b. And sorry, you might not be able to see that. And so let's plug in that other, the other points in the equation, which I will translate down here. And we have month 2 and month 9, right? And we have, I believe that was 99 and 112. Yes. 99 and 112. This is x, this is y. So if we plug that into this equation, so we know 99 equals 1.85, plug in x, 2 plus b. So we solve for b and we get 1.85 times 2 gives us 3.7 here, plus b equals 99. We subtract 3.7 here. We subtract 3.7 to both sides. And then we end up with b equaling to 95.3, right? So what is our total equation here after adding everything together? We get, and pardon me for the space, but y equals 1.85x plus 95.3. And that is our equation for this problem. And I know that's a lot of work, so I'll zoom out a little bit so you can see all the work there. But overall, it's pretty straightforward once you get the hang of it. It's just knowing what to plug in and when to plug it in, right? You're given points. So if you need to find your intercept, if you need to find your slope, you can do that with your given points. As long as you know how much the rate of change and kind of have an idea of what's going on in the plot itself, right? Okay, well, if you have any questions over this or any questions related to linear functions and generating them from plots or from problem statements, go ahead and put it in the comment section, and I will get to it as fast as I can. If you have any tips or advice for the channel, just let me know in the comment section below. All right, again, thanks for watching, and I'll see you in the next video.